Okay, today we're going to be continuing our work with laws of logarithms, section 4.4. We have 3 different laws of logarithms, and we're going to spend the entirety of this section talk about going back and forth between the two, because in the next section we're going to be looking at solving equations. In order to be able to solve equations, you have to go back and forth between these different condensed and expanded forms. So everything on the left is the condensed form, and everything on the right is the expanded form. So what happens is, if you remember, the logarithms are basically the exponents of the exponential functions. So anytime, if you go back to like the first couple of sections, if we were multiplying two bases together, what we would do is we would have to add those exponents. So it kind of works the same way. If we're multiplying two bases together, then that's equivalent to adding the a and the b in this case. If we're multiplying a times b, then that's the same as expanding it with the same base, but separating it into the two with the addition in between. The counterpart to that with division is, if I'm going to divide, that's the same thing as subtracting those logarithms. And then the last one, if you have an exponent here, then what we can do is we can bring that exponent down in front. And when we bring it down in front, then you would have like the c times log base a of a with that. So we're going to be working with these, going through quite a few examples just to kind of orient you to how these laws of logarithms work. Okay, the first one we're going to do is simply evaluate each expression. And I know you could go in and type these in your calculator. That's not what I want you to do. I want you to use the laws of logarithms to simplify it as far as possible before then using your calculator if necessary. So on this one, we really can't do a whole lot with this as it is. So what we're going to do is, since there is an addition symbol here, we know by our properties we could actually combine these together. We'll keep the base the same, and then we'll do 2 times 32, which is the log base 4 of 64. And now what we can do is we can rewrite the 64 as 4 to the third power. And going back to the properties that we learned last section, because these bases match up, then that whole thing is going to be equal to 3. So all of this equals 3 when you apply all the different properties and laws of logarithms. Okay, on this one, we've got a subtraction. So subtraction means what I'm going to do is I'm going to divide. So I'm going to divide the 80 by 5, which is going to give me 16. And 16 is 2 to the fourth power. So this is all going to equal 4. Keep in mind that these properties do not hold if the bases happen to be different. So if you have different bases, don't try to combine them together, only if they're the same. Okay, this one, if I have something in front, then I can pull it up as an exponent, or if I have something up as an exponent, I can bring it down in front. In this case, it's going to be to our advantage to bring it up as an exponent. So I'm going to have the log base 8 of negative 1/3. This is going to be the same thing as 1 over 8 to the 1/3, which is the cube root of 8. And the cube root of 8 is 1/2. Now here we don't have like bases, so we can't simplify this any further. So we're going to have to put this in our calculator. We'll do the common log of 1/2, and we get negative 0.301. And just follow your directions in WebAssign as to how many decimal places they expect on that. Okay, here are 3 for you to practice. I'm doing kind of the same thing we just got through doing. So I would suggest pausing it and then checking your work. Okay, on this one, I'm going to, because it's addition, I'm going to combine these together. That has a common log, a base 10. So I'm going to have 50 times 200. So I'm going to have log of 10,000, which is the same thing as 10 to the fourth power. And you know that for a common log, it has an understood base of 10. So that's going to simplify down to just be 4. This one, when I rewrite it, I'm going to have 60 over 15. So that's going to be log base 2 of 4. So the 2 and the 2 here, once I do this rewrite, is just going to make it be equal to 2. This one, I've got something in front that I'm going to take up as an exponent. Okay, this is the same thing as 3 to the 4th power, and then that's going to be raised to the 1/4. So I've got log base 3 of just 3, because the 4 and the 1/4 multiply together to give me 1. So my answer here is just going to be 1. Sometimes we're not asked to simplify it, but instead to specifically expand or condense our expression. So this one we're going to be expanding. So if we're expanding, then we want to break these apart. Okay, so for part A, we're going to have the log base 2. Multiplication splits up into addition. So I'm going to have log base 2 of 6 plus log base 2 of x. And that's really all we can do as far as splitting that up. B, we're going to split up Okay, if it's in its truly expanded form, we don't want to have any exponents left. So I'm going to bring those exponents down in front. So I have 3 log base 5 of x plus 6 log base 5 of y. And then for part C, we've got a combination of things here. So anything on the top is going to be positive. Anything on the bottom is going to be negative. So I'm going to do ln AB minus ln of the cube root of C. And some of these steps you can definitely combine together, but for this first time, I want to kind of show you, we're going to set this up as subtraction, and then I'm going to work from there. This is still the product of two things multiplied together, so I need to break that apart. And then this is the same thing as C to the 1/3 power. And again, we said in its expanded form, we don't want to have exponents left. So I'm going to bring this 1/3 down in front. And then that's going to be my expanded form for this one. Okay, here are 4 for you to practice with. So try these, see how you do with it. This is definitely one of those things that you have to get in and practice with. You can't just watch me do it. You have to do it yourself. So try these. Okay, the first one, we've got a product here. So we're going to do the log base 3 of 8 plus the log base 3 of x. Now on this one, if I could rewrite 8 as 3 to some power, I would want to do that and make that substitution, but I'm not able to do that with the 8. I'm going to have to leave it as it is for that one. For the second one, I have a product and I also have a power. Let's do the product first. So I'm going to break that into addition. And then again, we said when we're expanding, we don't want exponents left. So I'm going to go in and bring this 2 down in front. And I'll have this as my expanded expression. Okay, the third one, we've got a combination of multiplying and dividing. So let's do the division part first. We could do it all together, but I just suggest kind of taking it one step at a time. So we're going to have x to the 3rd, y to the 5th, minus log base 5 of z. So anything coming from the denominator is going to have negatives in front of it. Anything coming from the numerator is going to have positives in front of it. when we finish all of it. So here we've got a product, so we need to split that apart. So we'll have log base 5 of 3 plus log base 5 of y to the 5th minus log base 5 of z. So looking at this, we want to be sure that anything from the numerator is positive. So this one and this one are both positive. Anything from the denominator is negative. So this one's negative here. Okay, last thing, bring these exponents down. And we have our expanded expression. Okay, number 4, we're going to expand this one using the natural log, which uses the same properties. So we're going to have, I'm going to split up the division first of all. So I'm going to have natural log of the square root of 3x to the 5th minus the natural log of y. So this I'm not really going to be able to do anything else with. I'm going to rewrite this as 3x to the 5th to the 1/2 power. So since all this is to the 1/2 power, before I split this up, I actually want to take this power down in front. So here, each base was to an individual power, and that's why I split it up first. Here, everything is raised to this 1 power, so I'm going to bring this power down in front before I split anything up. Okay, now with the 1/2 down in front, I'm going to break this apart because it's the product of two things. So I'm never done until I have all products broken apart. So I'm going to have the ln of 3 plus the ln of x to the 5th minus ln of y. And there's one other thing that needs to be done on this one, and hopefully you see it, and that is that we can't have this exponent here. So I'm going to have 1/2 ln of 3 plus 5 ln of x minus ln of y. You could distribute this 1/2 to the fronts of each of these and have 1/2 ln of 3 plus 5/2 ln of x. It's up to you, however you want to do that. This is acceptable as far as an expanded form. Okay, so now that we've been expanding, I want us to go and do some where we combine. So I want you to think about if you were able to watch in reverse on a video exactly everything that we did, that's what we're going to be doing here. So we're going to go and just rewind everything that we did, and that's going to be how we do combining these. So here they are already expanded, and we want to combine. So if you remember, in most cases, the last thing we did was to bring our powers down in front. So when we're going to combine these, the first thing we're going to do is to take our powers up as exponents. So this is going to come up as an exponent, and this is going to come up as an exponent. So I have log base 10 of x to the 3rd plus log of x plus 1 to the 1/2. Okay, and then the next thing we can do is, because this is addition and we're wanting to combine it into one single logarithm, we can now multiply these two arguments together. And we'll have a single log, so we're only going to write log one time, x to the 3rd times x plus 1 to the 1/2. An alternative way to write this, which I'm not requiring, but you might see, is to go ahead and convert that to a radical. And so this would be that expression. Okay, moving on to, for part B, I'm going to come down here so I have room. We want to take each exponent up first. So I'm going to have ln of s squared plus ln of t to the 1/2 minus ln of t squared plus 1 to the 4th power. So moving each one of those up as an exponent. Now I want to combine it into a single logarithm. So anything that's positive will go in the numerator, anything negative will go in the denominator. So I'm going to have s to the 2nd t to the 1/2, and then here I'm going to have t squared plus 1 to the 4th power. And that's going to be the the condensed form of the logarithm. We only want to write log one time. We never, when we're combining it into the single logarithm, we don't want to have ln appearing more than one time in our expression. Okay, we'll be ready to do part C here. Okay, in part C, we want to combine these into a single logarithm. We don't have anything to bring up as exponents, so I'm going to combine it together into a single logarithm. Okay, so on this one, we are just going to be combining these together. When we want to combine these together, we've got addition, so we're going to combine into multiplication. So we're going to have an x times the 9 times the x squared plus 1. We're going to divide that by the 5 because that's the part that's being subtracted. So notice with this, we did not write log more than one time, and we combine anything that was positive goes in the numerator, anything negative is going to go to the denominator. Okay, here are 3 for you to practice with, so pause this, practice, and then check your work. Okay, the first one here, we want to bring each number in front up, so we're going to have log x squared minus log x plus 1 to the 3rd power. Combining it into a single logarithm, we're going to write log one time, and this is subtracted, so the positive term is going to go in the numerator, the negative one is going to go in the denominator. Okay, and so this would be our expression for that one. For the second one, we're going to begin by moving each coefficient up as an exponent. Okay, and then we're going to combine them together into a single logarithm. And as we said before, anything that's a positive term will go in the numerator. So this is positive, this one's negative, so I'm going to put it down here in the denominator. And then this one's positive, so it's going to go up in the numerator again. Okay, so that should be my expression for number 2. Number 3, I'm going to put over here. First step would be to bring each coefficient up. So we'll have an x to the 3rd plus log x plus 1 to the 5th minus log 2x to the 4th. Okay, we'll combine these into a single logarithm, and so that single logarithm, we're going to have the positive terms will go in the numerator, and the negative term is going to go in the denominator. Okay, and that should be your final answer. So I have one more example that I would like to show you because it's really combining quite a few things here. This one you've got a 1/2, but it's out in front of all this. So we're going to actually hold off on dealing with that 1/2 here. We're going to go ahead when we do this problem, and we're going to bring each of those up. So we'll have ln of x to the 3rd plus ln y to the 5th minus ln z to the 3rd. Okay, so I'm again going to hold off on this 1/2, and I'm going to combine these together into multiplication. Okay, and now that I have this all combined into one logarithm, I'm going to now take that up and do ln of x to the 3rd, y to the 5th, all to the 1/2 power, minus ln z to the 3rd. So then when I finish this off, I'm going to have, this would be the square root of x to the 3rd, y to the 5th, over z to the 3rd. Okay, so this is one approach. I do want to come over to the side over here and do a second approach. The second approach would be to distribute the 1/2 through. So this would be equivalent to 3/2 ln of x plus 5/2 ln of y minus ln of minus 3, sorry, I'm running out of room, 3 ln of z. Okay, here I can bring each one up as an exponent. And then I'm ready to combine these together. So I'd have x to the 3/2 times y to the 5/2 over z to the third. And this is actually equivalent to this down here, because an alternative way to write this would be x to the third, y to the fifth to the 1/2 over z to the third. The main thing is you have to get it to the point where you have a single logarithm. So if you're doing it this way, you've got to get it all the way down here. If you're doing it this way, you have to at least get it to this point. So those will be equivalent expressions there. Okay, the change of base formula is one additional thing that I'd like to look at today. The change of base formula will allow you to convert any logarithm with a different base into a common log. So the log of with base b of x would be the same as the log of base a of x over the log base a of b. So when that is beneficial is if I have something like this, then I could convert it to a common log so that I could easily evaluate it on my calculator, and it would be log of 3 divided by the log of 2. So the common log we know has a special key on the calculator. Some of you may be fortunate enough to have a key on your calculator that will allow you to do that without having to do the change of base formula. I'll show that in just a minute. But here on this one, you'd have the log base 5 divided by the log base, sorry, the log of 5 divided by the log of 8. These are common logs. Okay, and so when you divide that out, you're going to get 0.77398, again, depending on how many decimal places you're asked to convert that to. So we're just converting it to a log, to a common log there. Okay, the next one we've got on this one, we would have log, a common log of 20, and we're going to divide that by a common log of 9. So if we do common log of 20 divided by log of 9, we're going to get 1.36342 if we're doing that to 5 decimal places. Okay, if you have the button on your calculator to do a change of base formula, what you're going to do is you're going to go to the math key, which is on the left-hand side, and you're going to go down to where it says log base, and it's going to bring up a prompt that looks like this, where you can enter your base and your argument in that, and that'll give you your answer there when you do that. So it is possible, not all calculators have this, so you'll just have to check and see if yours does or does not. Okay, so here's 2 for you to practice with. And here are the answers that you should have gotten. Okay, so that takes us to the end of today's lesson. If you have any questions, please contact me, and hope you have a good day.